We have discussed in the previous class the various kinds of elements or various elements of the automated systems, which were, that is, the first one was the power to accomplish the process and operate the system. Second one is the program of instructions or set of instructions to direct the process. And the last one is the control system, which is actuating the instructions or set of instructions to the system. So coming on to our first element, that is we are discussing or doing these types of elements, elements of the automated systems in detail. And first one is the power source. What is the power source? That is the source which is being used to drive the machine, it is being used to drive the or to assess the all the controls of the machines. We are having different types of controls within the machines, like on off buttons, like we are having the sensors, transducers, which are providing the feedback system to the user. And the main source is the electrical source, or you can say the hydraulic power, or the pneumatic power may be used to actuate the system. So the power source is the first and the most important element of the automated system that is being used to operate the machine, to operate the spindle, to operate the particular kind of operation, and uh, so that the spindle may be ready for the current operation, as well as it is has been ready for the next kind of operation to be performed on the specimen. So the action performed basically by the power source are the processing, transfer, and positioning. So this is we are having the power source basically perform the two kind of operations. First one is the processing, and second is transfer and position. So what is processing for the power case? It is basically being used to accomplish some kind of operations on the job piece or the specimen. The process may involve fitting of the tool on the spindle and performing the operation on the specimen, and it may also involve shaping, molding, uninstalling, installing the tool, uninstalling and installing the workpiece, and setting the cutting conditions at the cutting area. And all these actions need a particular power source to be performed or to transmit that or to accomplish that processing, and to form one state or the other state into more valuable state or the conditions, so that the operations may be carried out accurately and precisely. So this is the first uh, action that is being performed by the power source, and second is the transfer and positioning. So while you are setting the position, or while you are setting the cutting conditions, or while you are positioning any specimen, or if you are dealing with the milling machine or the drilling machine, you are setting the workpiece table. And if you are performing the operation on the lathe machines like the turning operation, then you have to uh, fetch the tool from the tool library and perform the particular kind of operations. In the case of the lathe machines, we know that this is the the specimen is always moving, it is in the rotating manner or rotating position, whereas the tool is fixed in the case of the lathe machines, but it is vice versa in the case of the milling or the drilling machines. So in the case of the transfer and the positioning system, the product or the specimen must generally be moved from the one location to the other locations by the series of some processing steps, or you can say you are adjusting the longitudinal axis of the bed, you are adjusting the transverse axis of the bed, so that the operations may be performed precisely. So the power source is basically dealing the two actions. First one is the processing of the operations, and second is transfer or positioning the specimen or the workpiece, as the case may be. So second one is the that is the element of the automated system is the program of instructions. So what are program of instructions? We have already discussed this in various lectures also. That program of instruction is that action performed by that automated system or the automated process that are basically defined by the set of instructions known as the process. like we have to perform 5 kinds of operations on a specimen, and all types of set of instructions, that is which tool is to be used for particular operation, which kind of cutting conditions are to be used for the particular operation, and what will be the position of the tool and what will be the position of the specimen, so that that perform operation may be performed accurately. All these conditions, all these instructions, all these steps are to be mentioned in the program of instructions or set of instructions, that is called a program. So these set of instructions always determine that how that operation is to be performed automatically without any human assistance, and it also specify that which operation is to be performed, what is the sequence of operations, what are cutting conditions, and how its various components must function in order to accomplish the desired results on the specimen, and avoiding the wear and tear of the tool as well as the specimen by maintaining the cutting condition, by maintaining the accurate amount of liquid lubricants or the coolants at the cutting zone. So the second element is very very important, because these set of instructions are guiding the machine to perform a particular operation, and as well as these set of instructions, by entering these set of instructions, the human or the worker who is assisting the machine is totally free, and the machine is only fetching the particular set of instructions from the MCUs and performing that operation on the specimen. So this set of instruction is why it is important. It is removing the human assistance, it is removing the human error, and performing the operations actually as that it was been imagined by the R&D persons. So next one is the control systems. So we have the power source. We have initially started the machines by switching on the power. We have the set of instructions in the machines, but the last but not the least point is the implementation or the executions of all these set of instructions while to perform that particular operations. So without the help of the control system, we cannot execute these set of instructions, or we cannot implement, we cannot perform that operation on the specimens. So these control systems, so these control systems or the controls in the systems are very very important from for performing the operations accurately, because first one is a power source. We have started the machine. Second one was the set of instructions. This will be designed by either by the skilled worker or the engineer who is sitting in the R&D department. But the last element is the execution of these set of instructions whenever the machine is on. But these set of instructions are being executed only with the help of the control systems, because the worker is now controlling the machine. He is uh, uh, allowing the machine to fetch that particular kind of operations, to fetch the particular kind of set of instructions from the MCUs, and then that particular operation is being performed on the specimen. He's controlling the machine. He may be there may be any in the sequence of operation, there may be any operation which require more lubrication, which require more cutting speed, which require less feed rate. That all these may be controlled by a set of instructions, but the execution is only been possible by the skilled worker. So this control system is basically being the execution portion of the element of the automated system. So in control systems, we are having the input parameters, like we are having the input buttons, we are having the on off switches, we are having the any incremental coordinate systems, we are setting the absolute coordinate systems. So all these are the input parameters. For the actual output parameters, we are having the actual value of the parameter at the desired value. Let us say we want the diameter of the pipe or the diameter of the specimen must be 10 mm. It should not be 9.99 mm, or it should not be at 10.001 mm. Keeping in mind the tolerances also, the output must be within the range of the desired specifications. The sensor is also the controlling system, which is sensing the output variable, which is sensing the input variable, and which is sensing the input which is being transferred from the one part of the machine to the other part of the machines. And due to the closed loop nature of the CNC machines, it is providing continuously providing the feedback system to the R&D department as well as the skilled worker who is working on the machine, and sensing that whether a particular kind of operation is performing accurately, and which operation is to be performed in the next, and all that it is happening at the cutting zone, is it precisely happening or it is not. So it is providing whole kind of information to the user. So actuators, controllers, or the transducers all falls in the control systems which are being in the execution part. So due to the this data acquisitions and the information processing in most of the control systems, data must be collected from the process and used as input to the control algorithms. And next topic is the feature of work type cycles being programmed used in the automated system. So what are the features that may be required for work type cycle programs that will be used in the automated systems? So you can see there are some program features and their alternatives are available at the R&D department as well as to the with the skilled worker. So first one we can have, that is the steps in the work cycles. So steps in work cycles means there is a typical sequence of operations. That is, initially you have to load the specimen, you have to load the tool on the spindle, you have to load the specimen on the forja chuck. Then there is the execution of the process. As soon as the process or the whole kind of operations that are to be required to be performed on the specimen are completed, then the process is the unloading or the uninstalling the specimen and the tool from the spindle and the forja chuck respectively. Next is the process parameter. How you are controlling the process parameter. So one parameters versus the other parameters which may be changed or which may be which may require some modification in the coming steps. So continuous parameters versus the discrete parameters are the examples of the process parameters. Next is the manual steps in the work cycle. How the a particular work cycle is being performed manually by using the manual steps versus the no manual steps, or the operator loading or unloading parts to and from the machines. That is, the skilled worker is helping the specimen as well as the tool from the tool spindle to, for the uninstalling and the installing. And these are the features that are being lying for the work type cycle programs used in the automated systems. So I was talking about the various kinds of loops, that is closed loop system and open loop closed system. Closed systems in the case of the CNC machines, that is the control system, which is the third element of the automation system. So first one we'll discuss have the open loop control system. I think we may have read this in the construction and tooling chapter also, but I am again revising it here. So this is the open loop control system is basically applied whenever there is, we all know that we are using the conventional machines and we know that the worker is very skilled and he do not have any hindrance or do not have any obstruction while performing a particular kind of operation. He may not come with the any breakthrough or the downtime of the machine. But if you know that the worker is not the skilled worker, you always be assigned that worker to the closed loop CNC systems. But in the case of the open loop control systems, uh, you always think that all the operations are performing reliably or all the controls are being performing accurately by that particular worker, and all the actions that may be performed by the particular machine are very simple. They are not complex. They are not complex that cannot be readable, that cannot be judged by a skilled or unskilled worker. But in the case of the closed loop system, the actions or the operations or the sequence of operations may be complex because we have the system which can automatically judge, which can automatically imagine that what is going to be happen in the next course of action or what is currently happening in the cutting zone. So the reactions forces which are opposing the actuators are very small as compared to the reaction forces which are acting in the closed loop systems in the case of the open loop systems, and they do not have any effect on the actuation process. So open loop system, you can understand this from the main figure. I am coming to the next slide within few seconds. So closed loop systems, I am just having a glance on it again. So main difference is that we are having the feedback system. That feedback may be receiving to us in the form of the analog signal or the digital signal. And feedback also allows the machines or the CNC machines to know whether what is the currently going on in the machine and what is the next course of actions or what is the next position of the tool with respect to the previous positions, and is it happening correctly or not at the cutting zone, and it is, or whether the operation which is being going to perform or which is being currently being performed by the tool, whether it has fetched the correct tool, or the direction or the shape or the position of the specimen is correct or not. So you can see from this figure, that is, in the first figure we have the open loop system, and in the second figure we have the closed loop system. You can see in the open loop system we have some input device, which is the which may be this stepping motor, that is the power source, that is the first element of the automated systems. Then we are having the rotation of the lead screw on which the workpiece bed or the work table bed is being installed, on which the workpiece is being fixed. And then we are performing, let us say we are performing the drilling operation, and you can see the cursor of the mouse, that here this is the spindle or the shaft of the for assembling the tool here, and it is performing operation rightly perpendicular onto the specimen here. So as soon as the tool is performing the operation on the specimen, there is no feedback, there is no comparator, or there is no optical encoder, there is no feedback system as such is being installed on the system. So you can see, or if operation is performing correctly or not, it is whether the cutting conditions are correct, whether the position of the tool and specimen is correct. It is only being judged by the experience or the skill of the worker. If the worker is not skilled, he is not experienced person, then he cannot judge whether the operation is performing correctly or not. So after the operation, all the operations have been performed on the specimen, he can then check by the various tools to check the specimen. Then he may find that tool is incorrect or the specimen is incorrect. If the specimen is incorrect and it is not up to the mark as per the desired specifications being set by the customer, then he has to again perform the all kinds of operations on the specimen. Then that specimen which was initially was not up to the mark as per the desired expectations of the customer, then it may lead to the generation of more scrap. So if it is generating more scrap, that is we are creating more loss to the company. So skilled workers may be required for performing operation on the open loop control systems or the open loop CNC machines. Whereas in the case of the closed loop, you can see in the figure that we are having the servo motor, we are having the comparator initially, from which the input is being stored, and it is being compared as soon as it is being received from the optical encoders. We have read the optical encoders in the fourth chapter, that is in the system devices, that it is receiving the signal in the form of the let us say digital signal, and it is sending the signal in the form of digital uh, form to the comparator, and comparator is comparing the earlier stored data with the data which is being received after the operation is being performed, and it is comparing the actual data with the saved data. And if the data is found to be correct, that is, it is providing the feedback in the form of analog or digital signal that operation is performed correctly. But if there is any mismatch in between the stored data as well as the data that is being received after the operation is being performed on the specimen, then came to know that there is some uh, discrepancy in the operation, there is some discrepancy in the specimen, there is some discrepancy in the cutting operation. That feedback signal is provide the feedback that where is the problem, where is the discrepancy. It also provide the location, it also provide the exact signal, or it provide the exact location, it provide the exact discrepancy in the signal. So you can see in this is a closed loop system where we're having a servo motor which is getting the power source and the workpiece table. We are performing the same drilling operation on the specimen is fixed, and the operation is performed right at the axis of the specimen, and the drilling machine are uh, right angle to each other, and also performing the operation on the specimen. But here we are having the linear motion of the work table, and as soon as the operation is being performed on the specimen, the optical encoder is receiving the signal and continuously sending the signal to the comparator. And comparator, as I have earlier told, it is comparing the earlier stored data with the receiving data, and within the operations and after the operations, it will send the feedback signal. During the operation, it is sending the mm, signal up to which mark or up to which sequence of operation the operations has been performed. Let us say we have to perform five kinds of operations in a sequence 2 1 3 5 4. That is, the sequence is 2 1 3 5 4, and after each kind of operation, it is sending the signal to the comparator and it is comparing. At each step, we came to know that the operations are performing correctly. Let us say after the or during the operation, second operation, or during the operation 1, that is 2 1, the second operation is obviously 2 1 3 5 3 4 2 1 3 5 4. So 1 is the second number of operation which is to be performed on the specimen. So whenever the second operation is completed or whenever the second operation is performing on the specimen, it is sending the instant signal to the comparator and is comparing. At every moment we can check whether our operation is performing accurately or not. So due to this closed loop nature of the CNC machines, they are more desirable, they are more preferable in the automated industry nowadays, so that with the help of these kinds of CNC machines, we are always decreasing the scrap. We are decreasing the cost of manufacturing. We are decreasing the scrap. We are reducing the lead times, and also we are our productivity, our production level is more in the same working hours, and also it is the industries are becoming more competitive in the global market due to these kinds of natures of the control systems. Next is the advantage of automations. So advantage I have already told you in the previous slide also, the closed loop systems. So let us have a glance on these advantages. So that is, we are having lesser manufacturing lead time. We are eliminated the setup time, that is the loading unloading time we have reduced, because in the earlier times the workers are the skilled workers are basically assembling the specimen, they are uninstalling the specimen, they are fitting a tool at the desired angle. But here only the set with the help of the set of instructions, the machine is fetching the instructions from the control unit and performing the operations by fetching the tool from the tool library onto the specimen, and there will be no setup time. So we have reduced the setup time. We have also uh, make available the safer conditions to the worker who are performing the machines, because I have shown you see the pictorial view of the CNC machines in our first class, that CNC machine is totally covered. There will be no chances of any accidental that may occur in the previous cases in the conventional machines to the worker. There is no flow of chips around here and there. The chips or the all the things or all the lubricating oil that is being used in the cutting conditions are all being stored in the lower portion of the machines. We are getting the high quality product at the optimum cost, and also there are more employment opportunity for the skilled workers. And if they are getting the highly paid salaries, if they are getting more salaries, if the worker is very skilled and getting the higher salaries, then naturally the standard of living, their standard of their living life will be increased. So ultimately it has benefited the whole society, it has benefited the industry, it has benefited the engineers, it has benefited the worker also, who is having some skill to perform the operations on the CNC's machines. So in all, the automation has benefited the societal needs. It has benefited the society from the upper level, upper middle class to the lower middle class, from the high standard society to the low standard society. So there, if some roses are there, there are some horns are always there. So there are some demerits of automation also, because there is always retrenchment, there is always be unemployment for the unskilled workers. They cannot find job for the in the industry because they are not skilled, they cannot use or they cannot run CNC machines. So there always be chances of unemployment, lower skill levels of the worker, there may be retrenchment, they may be fired from the industries, and they do not find the accurate job. So the society which is not skilled, which do not have any sources to be learned or to get the knowledge of the CNC machines, they cannot be paid. higher salaries. So the salaries have been reduced, and also the number of workers who are using in the who are being employed for the CNC machine, the CNCs have been less, because all the operations are to be carried out with the help of the set of instructions which are being stored in the machine. So the human assistance has always been reduced. Let us say in the earlier days, if 50 workers are being required in one shop floor, but nowadays only 25 to 30 workers are controlling the same kind of machines. But the machines are nowadays are CNC machines. So the 20 persons who have lost their jobs have uh, the discouragement, or they have the retrenchment, or they are suffering from the unemployment in the market. And also the peoples, due to the high inflation rate of the market, due to high there are some government policies due to which the purchasing power of the customer, the purchasing power of the people have reduced nowadays. And the system changes are sometimes are very difficult to be adapted. Like if you are getting up at 7 a.m. Daily, but if your parents will ask you to get up at 6 a.m. from tomorrow onwards, and you will always be resist to that decision of theirs. But similarly, if the industry is implementing the CNC machine, it is implementing automation in the industry, the old workers who are not enough skilled, they always resist. They always find difficult to understand what is happening in the industry, and what is how they are being how the operations are being performed. So system changes, or the change in the system is always be resistable to everybody, and they're always be slow to implement. Why it is slow to implement? Because industries always have the worker unions, they always resist because of the fear of their unemployment, because of fear of their retrenchment, and also the loss of their job. So this may lead to the demerits of the automations. And what are now applications of the automations? We'll do these applications of automations in our next class.